Hi class. Today I think I'm going to share with you some simple comparative statics in using just a labor-leisure model with no household production, and we will lead up to the total model, which includes household production, market time, and leisure. So starting with a constraint, we have the price of consumption times consumption is equal to WT plus V. In other words, we expend all our income. But we don't really know much about time. We want to look at labor and leisure. So we say PC, price of consumption, times consumption, equals WT minus L plus V, where T minus leisure is equal to M. And rewriting, we can have the price of consumption times consumption plus the wage rate times leisure exhausts WT plus V. Remember, WT plus V is the total the total amount I could earn if I worked every hour that I had, 168 hours in a week, and added my non-wage income. So I wish I could do better at this. T equals 168. We have V. We measure goods, C. We measure time. And here we have for every hour you're earning W, so this maximum is WT plus V. I can put in a budget constraint, and I can identify in this graph that I will spend OA time in market work and AB time in leisure. So that's a starting point for looking at a market work leisure model with no household production. Now, when I do this, I can change the wage rate in several different ways. So let's start looking at comparative statics. $168, 0 hours. I have some non-wage income. My budget constraint, WT plus V. If I worked every hour in the labor market, I measure goods, I measure time, and I have some starting point where OA is hours of market work and AB is hours of leisure. Now, what could possibly change my wage rate? My wage could increase, I could get a raise. My wage could decrease, as in when there was a recession, airline pilots were asked to all take a decrease in their salary, and their salary is based on their wage rate times the number of hours that they work, so their wage would decrease. I could also have an income tax on earned income, not V, earned income that is tied to my wage. An income tax would decrease the wage rate. Or I could say, let's relieve and put income taxes down, and that would be an increase in the wage rate. So let's say that we increase income taxes. And when you increase income taxes, you decrease the wage. Therefore, W times every hour you work is less. And I will have some indifference curve. And I can put A prime. And I can see that the total effect here is to decrease my amount of market work and increase my amount of leisure from this black line to this red line. So when I decreased my wage rate, the total effect was the movement, total effect. The original was OA. The new is OA prime for market work. And for leisure, the original was A, B, and the new is A prime B. Leisure increases, market work decreases in this case. But we can break this total effect down into what we call now a consumption substitution effect and an income effect. So let's look at this. How do I identify my substitution effect when I have a change in the price? The change in the price of time is the wage rate. I draw a line parallel to the new and difference curve, tangent to the original budget line. This is less steep, therefore there's my parallel line. And we're going to call this Q star. The movement from A to Q star is my consumption substitution effect. So what's happened? Leisure has become less expensive. I substitute into it. Notice I'm taking more leisure. That would be the movement from here to here. Substitute into leisure. And my income effect is the movement from Q star to A prime. And I'm now taking less leisure because leisure is a normal good. I have less real income. I take less leisure. So the consumption substitution effect, when I decrease the wage rate, says leisure less expensive, substitute into it. The income effect says when the wage rate goes down, real income decreases, leisure is normal. Take more of it. So I've substituted into leisure, and the income effect pulls me out of leisure, saying that ultimately I did take less market work and more leisure because the substitution effect into leisure, because it was less expensive, was bigger than the income effect out of leisure. That's the consumption substitution effect and the income effect. So this consumption substitution effect looks at the trade-off between L and M, leisure and market work. The income effect looks at the relationship between L and market work. If the wage rate goes down, leisure is less expensive. Substitute in. When the wage rate goes down, real income decreases. Leisure is normal. Take less. So the consumption substitution effect saying increase leisure goes against the income effect, which says take less leisure, and ultimately the answer is an empirical question that depends on preferences and the size of the wage decrease. Seems pretty complicated. Let's do a wage increase. If I increase the wage rate, that means I have decreased taxes or given you a raise. Every hour of market work gives you more income. So I can start with an indifference curve that says OAB or OA, sorry about that, is equal to market work, and AB is equal to your leisure time. After the change, OA prime is equal to market work, and A prime B is equal to leisure. This is the total effect. Can I break that down? Well, I draw a line tangent to the original indifference curve, black, parallel to the new budget line. The new budget line is steeper. There's my Q star. What's happened with Q star? This is your consumption substitution effect. A to Q star, consumption substitution effect. What happened? The wage rate went up. Leisure became more expensive. I substitute out of leisure. Now what's happened? Oh, now I have a real income effect that goes up. Income increases. Leisure is normal. Take more. So I have a consumption substitution effect saying substitute out of the market and into leisure because leisure costs more. So I substitute out of leisure, and my income effect says, oh, leisure's a normal good. I have more income. Take more leisure. Once again, I have an empirical question. And when you change the wage rate and you only have a labor-leisure model, the consumption substitution effect and the income effect determine where you will end up. So we really have a change in leisure given a change in a wage equals a change in leisure given a change in wage, holding utility constant, minus a change in leisure given a change in income multiplied by leisure. This is your Slutsky equation, only this is now a consumption substitution effect, and this is an income effect. If the wage increases, I sub out of leisure because it's more expensive. Income decreases, take less leisure because income went down. When the wage rate decreases, sub into leisure because leisure is less expensive. Whoops, I'm sorry. Income goes up. Oh, take more. When the wage rate goes down, income decreases. Take less leisure. Leisure is normal. Okay, so hopefully that cleans up the discussion about consumption substitution effects and income effects. we have one more thing to go through, and that would be we need to add the production substitution effect. And what we're going to find with a change in the wage rate is a change in a wage rate, change in leisure given a change in the wage rate equals a change in leisure given a change in the wage rate, utility equals constant, minus a change in leisure given a change in income multiplied by leisure. When we add production, household production into here, this is going to equal a production substitution effect plus a consumption substitution effect combined with the income effect. This combined is the old substitution effect that we looked at.